All right, everybody, welcome back here. Lesson 6.8, Graphing Radicals. Um, as expected, we should learn a lot about graphing radicals with what we already know about graphing certain functions, okay, using A, H, and K. Okay, so just like everything else, we have our parent graph, and then we want to shift things up or down. So that's our K value outside. And our horizontally shifting is within the radical, which is going to be your horizontal or vertical shift, referring to H. And then you can put it all together, move up, down, left, right, okay, whatever you decide to do, okay. Same thing here again. If you want to flip it and reflect it about the x-axis, okay, you just make it opposite, and then the A value will stretch or compress as necessary. A value greater than 1 will vertically stretch it. A value between 0 and 1 will compress it. Again, everything is compared to our absolute value graph here, but all of this remains the same. Okay, so we have two graphs we're going to look at today. Okay, the first one is the square root graph. Okay, so it's pretty much half of a parabola on its side. Okay, I refer to it as a sleeping parabola. So if it's positive, it's the top half. Okay, if we were to do negative, it would just be the bottom half down here. Okay, so right now we're just in with the positive. That would be the parent that we're looking at. A negative would flip it, vertically stretch it. It would go this way. Okay, a vertical compression. Okay, again, you're stepping on it. It's going that way, and then we can shift it up, down, left, and right accordingly. Okay. Your locator point in this situation would be your end point, okay, right here. All right, and the reason it starts and stops, okay, where it begins right there is because you cannot take the square root of a negative. All right, so again, all things that you already know, so we can quickly review that. Okay, the other graph is a cube root graph. Okay, so this, if we would turn it vertically, it would look like a cubic. Okay, but again, we lay it on its side and it looks like that. So it's almost like this half of the graph is the square root graph. Okay, but it is stretched horizontally a little bit. Okay, the numbers aren't exactly the same because of the cube root. Okay, and then it looks like if we swivel that down on the bottom and then reflect it about the y-axis, okay, that's like the underside of it, but it goes the opposite direction. Okay, the locator point in this case is called the point of inflection. Okay, that's the point where it changes directions. Okay, it goes from going up to opening down. All right, but everything is the same. H and K stay the same, horizontal shifting and vertical shifting. If our A value is greater than 1, okay, it's going to look like this. All right, and then if our A value is between 0 and 1, it's going to be a lot tighter. A lot tighter of a little squiggle there. Okay. Here, this domain and range is all real numbers, forever and ever left and right, and forever and ever up and down. Because you can cube root any number, we don't have that restriction of not being able to cube root a negative like we do with the square root. Okay, one thing that I did do that's not on your table, the table that we have here. All right, I just tried to follow a pattern. Up here, this is, if we clear this out, to get our points here, all right, we see this, we go up 1 over 1, and then up 1 over 3, up 1 over 5. It's just like our parabola, but it's on its side. Okay, so we can still use this idea as a shortcut, okay, the 1, 3, 5, but we're going to go 1, 3, 5 horizontally. All right, so I try to do the same idea here. This way we're going, up 1, out 1, up 1, out 7, up 1, out 19. And then this side here, we're going down 1, left 1, down 1, left 7, down 1, left 19. Okay, not as easily recognizable as a pattern, nor do we have the graph space usually to graph all these, but we should at least be able to get the first couple of points. Okay, and again, the A value here for both of these only affects the vertical change in the graph. Okay, so whatever A value is would only affect that number. You'll still have your 1, 3, 5, 7 pattern horizontally, But if my A value is 3, then I'm going to go up 3 over 1, up 3 over 5, up 3, up 3 over 3, up 3 over 5. Okay, same thing down here. The A value will only affect that vertical change. So you're still going to go up 1, out 1, up 1, out 7, up 1, out 19. But if the A value's 0.5 now you're only going up a half. Okay, over 1, up a half, over 7, up a half, over 19. Okay. So real quick, just want to review some of these, draw a couple, sketch a couple real quick, identify the graph transformations and translations, and then give a quick sketch, and then get you guys wrapped up for this lesson. Okay, so first we're going to look at the square root of x and then plus 3. So we look at this. Okay, our A value is positive, so we know that's going to open up. Okay, we'll have the top half of that graph. It is 1, therefore there is no vertical stretch or compression. Okay, it just remains the parent. Here, there's no horizontal shift. Okay, and the plus 3 means we're going up 3. Okay, so our locator point, our starting point, is going to be 0, 3. All right, so what I have here, I just graphed the parent. I'm going to try and be somewhat tech savvy and just kind of move this graph around. So I'm going to copy this, and then I'm going to hold off on pasting it. So 0, 3, we're sliding this graph up 3. So here is my locator point of 0, 3. All right, so if I just take, I could just go up 1, out 1, up 1, out, 1, 2, 3, up 1, out, 1, 2, 3, 4, 5 to get my points. Okay, and draw this graph. All right, which should be the exact same thing as if I were to take this guy and then paste it. It should line up exactly right there. All right, so we're just sliding that guy around because there is no vertical stretch or compression factor. Okay, so let's look at the one down here. Again, same thing, still going up, no vertical stretch or compression, so nothing to worry about there. Okay, the horizontal shift is 0. Okay, and the vertical shift is going down 1. So really all I'm doing is picking that graph up and sliding it down 1 unit. Okay, so the same patterns occur, up 1, out 1, up 1, out 3, up 1, out 5. All right, if I copy this graph again, I should be able to slide that right over top of the points I just made. Okay, and I made a mistake down there with that blue point. That one there should be up. Okay. So real quick and easy. Nothing we really haven't learned before. The only thing that's different is the shape of the graph. Okay, let's try a couple more. So this one here opens up. Okay, there's no vertical stretch compression. Here we went left 2. And there's no horizontal shift down here, so it's no vertical shift. Okay, no vertical shift out there, so your vertex is going to be, or your starting point, left 2, up or down 0. So we're going to go negative 2, 0, and then do our 1, 3, 5 pattern horizontally. All right. So there's that one. Same thing with this one. This one's going to be a little different because now this one's going down. Okay, it's going to open down. Still no vertical stretch or compression. Okay, and we are going right 4, but up or down 0. So no vertical. Which puts us at a starting point of 4, 0. Okay, but now because it's going down, I'm going to go down 1 over 1, down 1 over 3, down 1 over 5, which puts me off. Okay, so again, just reiterating that, starting from here to here to here, okay, the 1, 3, 5 pattern horizontally. Okay, and our A value is going to affect this number here. Normally it's 1. Okay, so whatever our A value is, we'll multiply that by. And our 1, 3, 5 horizontally will remain the same. Okay, which we're going to see right here. Okay, so y equals 3 times the absolute value, or 3, y equals 3 times the square root of x plus 1 minus 3. So this one is positive, so it will open up. 3 means it's going to be vertically stretched. Left 1 and down 3. So your starting point is left 1, down 3. So that's where we will begin. -1, -3. So remember before, we had this pattern, okay, where normally this was 1. Okay, this is 1, 3, 5. And because this a value is 3, I'm going to multiply each of these vertical changes by 3. So now, instead of going up 1, 1 times 3 is 3, 3, 3. So you're going to go up 3, 1, 2, 3 units, and over 1. And then up 3 more units, 1, 2, 3, and over 3, 1, 2, 3. And up 3 units and over 5, 1, 2, 3, 1, 2, 3, 4, 5. Okay. Okay, so just pulling out a couple of the nice points. Whenever you're in doubt, I mean, you can always pull out your graphing calculator here. Okay, you can type in that equation and just confirm some of the points. For some of you, that helps put you at ease to know that you're right. Okay, and likewise for me too. Oops. And then -3. Okay, you can look at a graph. All right. And then we can look at our table just to confirm some of the points that we have. Okay, so we have -1, -3. We got 0, 0. There's 3, 3. And the last one we did on our graph that fit was 8, 6. Okay, so that confirms our graph is accurate. Our shape is accurate. And it begins right there at -1, -3. Okay? So it's nice to have that little shortcut 1, 3, 5, whether it's for your parabola going vertically or when you lay it down on its side and make it the square root, you do your 1, 3, 5 horizontally. Okay? All right, let's practice a couple of these. Okay, this is the cube root graph. So I graphed the parent there in black over on my graph already. All right, just plotted the important points. Okay, the cube root of 1, 0, 1, and 8, and then the negatives, -1 and -8. All right, so that one's in black. Okay, the second one, all right, we'll do over here. So what's happening? Okay, there's no, it's going to face the same direction. Okay, if it were negative, it would go this way. Okay, if it were negative, it would go this way. All right, so that's the only difference. That's how it would flip. All right. We don't have to worry about that. Okay, it's going to face the same direction as the parent. There's no vertical stretch or compression. Okay, and this one's going right 5 and up 3. So this is the point, my locator point, that I'm going to move to 5, 3. All right, and I can take this exact graph and then move that point right there. Okay, so that's how we would move that guy. Again, if we follow we don't have a 1, 3, 5 pattern. We set up here, we had a 1, 7, 19 pattern. Okay. All right, let's try one without actually copying and pasting the graph. All right, so again, faces the same way as the parent, no vertical stretch or compression. Okay, here we're going left 4 and down 2. Okay, so our locator point is going to be -4, -2. -4, -2 is there. All right, we're going to go up 1 and over 1, and then up 1 over 7. 1, 2, 3, 4, 5, 6, 7. And that's all I have room for. I'm just going to do the same thing going left and down. So down 1 over 1. Then down 1, left 7. 1, 2, 3, 4, 5, 6, 7 puts me out there. So that looks like -12, -4, -5, -3. We got -4, 4, -2, -3, -1, and then 4, 0. So what we're going to do is connect these dots. So it's almost like, whoop, I don't want to hold on to it too long. Half a parabola opening up to the right, and then half parabola opening down to the left. Okay, and there's our point of inflection. All right, real quick before we end this thing, just want to confirm some of these points here with that last equation in our graph. All right, so if we go to y equals, okay, the cube root is option 4 in math of x plus 4 and then -2. All right, there's our graph. Okay, it looks pretty close as far as location. Let's confirm a couple points in our table. All right, so -12, -4 is there. -5, -3. -4, -2, -3, -1. Our last one is 4, 0, and there it is. Okay, so it's amazing what you can do without a graphing calculator if you recognize and understand the patterns, how things shift vertically, horizontally, how they reflect if it's negative, and how they vertically stretch or compress. Okay, so once again, we said this from the beginning. Once you learn all this graph shifting translation process for one graph, okay, it just simply applies to all the other graphs. The only thing that changes is the shape of the graph. Okay, so if you have any questions with this, please ask them when you come back to school. Thanks a lot, guys.